Okay, actually this video is a continuation from the problems video before this. Yeah, because actually some technical problems happened, and I paused record and I forget to continue record again. Yeah, so I made a new video to continue with the previous problem video. Okay, so you must refer this video to the previous problem video. Yeah, okay. So just now I want to draw free body diagram for each of these three blocks. Okay, so I have drawn already the free body diagram for all these three blocks. Yeah, so what you can see over here is yeah, this is the free body diagram. Okay, all of these you can see this free body diagram don't have the blocks. Yeah, because free body diagram is only one point. Yeah, for our chapter here. For this chapter, we only consider all the masses as point mass, as you can see. Okay, so no blocks at all. Yeah, no blocks at all. Now, okay, so this is the free body diagram for mass 1. As you can see, the pushing force initially is at the left hand side, isn't it? This is the pushing force is at the left hand side, but we don't draw it at the left hand side. We need to put it over to the right hand side. Yeah, drag it over to the other side, but maintain the same direction to the right. Maintain the same direction to the right. We cannot draw. We cannot draw the direction pushing force. We cannot like this. Pushing force to the right. So we draw over here. Pushing force over here. Cannot. Yeah, cannot. Later on, you will have troubles when you try to do calculations and formulas. Okay, drag it to the other side. Make all the force outwards from the. Remember, all forces. Okay, I just want to write something over here. Yeah. Okay. So remember, all forces must outwards from the dot. Cannot inwards the dot. So this pushing force, I drag it over. I drag over. Don't draw at the left hand side. Draw at the right hand side. Same thing goes to this blocking force from mass 2 F21. You cannot draw. In other words, you cannot draw like this. You cannot draw like this. Pushing force over here, and then the F21 over here. Cannot. Yeah. Don't draw like this. Similar things goes to mass 2. You cannot draw F12. You cannot draw the F12 over here. F12, and then F32 over here. This is wrong. Yeah. And also for the mass 3, don't you go to draw F23 over here. Okay, this is all wrong. Yeah, this is all wrong. Yeah, this is all wrong. Cannot draw like that. This one is wrong. All these are wrong. Don't you go to draw like this. Yeah, don't draw all the force towards the point. The force, like pushing force, you need to drag it over to the other side. F21 also to the other side. This F12 go to the other side, and F32 go to the other side. Okay, but maintain the same direction. Yeah, and F23 also drag to the other side. Yeah, make it outwards from the point. So remember this. All forces must outwards from the dot. So I pushing force, I drag to here. F21 over here. Okay, so this is the correct one. Okay, this is the correct one. F12, I drag it over here. F32 over here. Okay, so then that is correct. Okay, same thing goes to F23. Go to the other side. Become over here. That's correct. Okay, I hope you understand this. Yeah, all forces must outwards from the dot. Okay, and then another thing is all this weight you must label with W1, W2, W3. Don't put as W, W, W. No, because they have different weight. Different weight must have different subscript. Okay, so must have different subscript. Must have W1, W2, W3. And also the normal force, don't put n only. You must put they have different normal force. You must put N3, N2, N1. Different, all different. Acceleration, you need to draw beside the dot, not on the dot. Don't draw it. Don't draw it. Oh, acceleration. Acceleration, the dot accelerate to the right. No, because acceleration is not a force. Acceleration, I repeat, acceleration is not a force. Acceleration is just acceleration. Only the force are allowed to draw from the dot, like pushing force, normal force, weight, contact force, F21. All these are forces that are allowed to draw on the dot. Acceleration is not a force. Acceleration is not a force, not allowed to draw on the dot. You must draw acceleration just beside the dot. Okay? So don't draw it on the dot. The acceleration. They are not in, acceleration is not in the same group. Okay, same group. Not the same category. So acceleration just draw beside. Okay, so rub it off. So we complete already. These are the 3 separate free body diagram for three objects. 3 objects, you must have 3 separate free body diagram. Okay. Now, this is the one. This F21 and this F12, they are equal. Okay. This force and this force, F21 and F12, they are equal. And then this F32 and F23, they are equal. F232 and F23, they are equal. Okay. The pushing force only push on MS1. It doesn't directly push on MES2 or MES3. It is the MES1 who push MES2, MES2 who push MES3. Okay, pushing force doesn't push MES2 and MES3 directly. Okay, although that F12 is actually part of pushing force, F23 also actually part of pushing force. But pushing force never push directly MES2 and MES3. So pushing force only push directly on MES1. As you can see. So that's why pushing force only exists on MES1. Okay, never exists on MES2 and MES3. Okay. So like you see here, for all these 3 meshes, we need to do X and Y component for both of them. Okay. So we have a 6 formula. 1, 2, 3, 4, 5, 6. With 2 formulas for each meshes. Okay. But the easy things for this question is, luckily this question is frictionless. Frictionless. The surface is frictionless. That means it's smooth. The surface is smooth. So when smooth, it doesn't have friction. It doesn't have friction. The kinetic friction, which is equal to mu kn, is equal to 0. No friction. So when no friction, you no need to investigate the normal force. Understand? When no friction, no need to investigate the normal force. Because the normal force only can be found in the y component. Understand or not? So this question is have a smooth surface, so has no friction. So you no need to find the y component because we no need to find friction. We no need to find friction, so we no need to find what the normal force. And that's why we also no need to do y components. No need to do y components formula. Understand or not? But I will show you how to build equation for y component also, just in case. Just in case got friction. Just in case got friction. Later I will show you. Okay. Now, okay, let's go. Let's go. Let's go. So now we want to build formula for the x and y component. Okay. Hold on a second. Okay, now I shall start. Okay, so for x component, let's say look at MES1. Okay, look at MES1. So for x component, this is the x component and this is the y component. Okay, maybe I should just write, this is the x, x, x. This is the y, y, y. Okay. Now, look at the x component. X component has acceleration. Okay, has acceleration. So for x component is total F equal to ma. Total Fx is equal to ma. Because got acceleration. Got acceleration. But the y component, no acceleration. No acceleration, so it is 0. Total Fy is 0 because no acceleration. Okay, acceleration only in x component. Okay, so if you have acceleration, you need to compare with acceleration. Okay, you need to compare with acceleration. So like this one, if you have acceleration, total F equal to ma, you need to compare with acceleration. Follow acceleration is positive force, opposite acceleration is negative force. So look at this one. So this one, s component, acceleration to the right. Acceleration to the right. So the forces to the right is positive. Forces to the left is negative. Follow acceleration, positive. Opposite acceleration is negative. Okay. So now we write it down. So pushing force is positive. Pushing force. Positive pushing force, but negative F21. Negative F21. Okay. And what mass is this? This is mass 1. Put as mass 1. Put as mass 1. Okay, what is the mass? 3.5, 4, and 5. Okay, write it down over here for easier to get the information easier. This is 3.5 kilo. This is 4 kilogram. And this is 5 kilogram. Okay, is that correct? 3.5, 4, and 5. Yeah? Yes, it's correct. 3.5, 4, and 5. Okay, and the force is 30 Newton. 30 Newton. So this pushing force is 30 Newton. Okay, that's it. So now write it down. This mass 1 is 3.5. Put as 3.5 acceleration. Okay, so now pushing force, this one pushing force is 30 Newton. Just put as 30. 30. And then minus F21 equal to 3.5. Oh, actually acceleration just now we got already, isn't it? Actually this acceleration already discussed in previous video. In previous video already got the acceleration 2.4. I already got the acceleration 2.4 in previous video. So please check out the previous video. I already calculated the acceleration when I use the shortcut. When you use the shortcut for the whole system, this is just a shortcut to find acceleration directly. We combine all three masses as one object. I can directly find the acceleration. So I got the acceleration 2.4 already. I can straight away put in here. So I can straight away put the 2.4 over here. 2.4, I can put it over here. So that means it's easier this way because I don't need to do all simultaneous equation just to get this F21 and acceleration. With the shortcut just now, actually it saved me a lot of time. Okay, I got the acceleration here. I just put into here. I can straight away find the contact force for F21. Well, F21. So actually, in a way, it is much faster. Yeah. Okay, so I got the acceleration over here. I can put it here, and then now I want to calculate F21. Yeah, F21. Let's calculate. Okay, hold on a second. I rearrange first. This one go to the other side. So it become F21, which is and then this one go to here, become negative. So it's actually 30 minus 3.5, 2.4. So what answer do I get? Let's calculate. So I got it is F21 is 21.6 Newton. I got F21 already. Okay, 21.6 Newton. Okay, so that's the answer. F21 21.6 Newton. And then one thing is we can say that this one we can say this. After that we can say this about this one. F21 is actually F12 because it is F21 is actually same equal to F12 because they are action reaction force. You understand? I can put over here, yeah, between the mass 1 and mass 2. F21 is actually F12. So is that means it is equal to 21.6 Newton. Yeah, 21.6. Yeah. Although it is opposite direction, it got negative, but no need lah, just ignore the negative sign. We just want the magnitude. Okay, so I can carry forward this 21.6 Newton into here to solve here. Understand? Actually, I got the answer already. Is that answer correct? This is the contact force between the mass 1 and mass 2. Okay, this is a contact force between mass 1 and mass 2. Is that correct? Between mass 1 and mass 2, 21.6 Newton. That's correct. Okay, 21.6 Newton. That's correct. Yeah, that's correct. 21.6 Newton. Okay, problem solved already. This question already solved. Okay, but actually I want to guide you also for the other objects. Yeah, I want to guide you also. What if the question, let's say I add one more questions. Let's say question C. Let's say question C now. Find also the contact force. Contact force between what? Between mass 2 and mass 3. So what is that? What is the contact force between mass 2 and mass 3? So you need to do this one or this one. You need to begin with the mass 2 or you begin with mass 3. Okay. So let's do it. Yeah, why not? Let's do it. Okay. Okay, for part B I already solved. Okay, never mind. Let us continue. Okay. Do one by one. Yeah, we already solved the S component for mass 1. Let's see the Y component for mass 1. Although it's not necessary, because this question has no friction. It has no friction. So actually we no need to find the normal force from Y components. But what if the question has a friction? If you have friction, you need to find the normal force. You need to consider the Y components. Okay, so that's what I need to teach you also. Okay, so let's do the Y components. Make it maybe make it green color. I like green a lot. Yeah. Okay, so let's do the Y components. So the Y component has no acceleration, isn't it? No acceleration. So we just take we have no acceleration to compare. No acceleration to compare. So we just take direction upward positive, direction downward direction upward positive, direction downward negative. That's it. Okay, so okay, continue. So we have the n1 is positive and then the weight is negative. So negative weight. Okay. Oh, so why is it I want green? Okay, so yep. Okay, so that's why my normal force now, my normal force 1 is equal to the weight. So I got the normal force for 1. Okay, now look at the mass 2. Mass 2, it has look at the x component. X component, it has acceleration. So total Fx is equal to mass 2a. Mass 2a. Okay, it has acceleration. So follow acceleration is positive force. Opposite acceleration is negative force. So we can see F12 is a positive force, F32 is a negative force. Okay, so F12 is a positive force. Okay, we don't just put F12, it is positive. but F32 is negative, so just put a negative sign, and then F32. Okay, and what mass is it? 4 kilograms, so it is a 4 acceleration. Okay, so now okay, we can find it. What is that? Okay, so so this is F12 is a positive force, F32 is a negative force. Okay, so F12 just now we got it is a 21.6, isn't it? So we can substitute over here 21.6 and then minus F32. We don't have that. Acceleration we also have. Acceleration is 2.4. Acceleration is 2.4. Okay, that is acceleration is 2.4. So now we can get F32. F32. Let's calculate. Yes, I got the answer is 12 Newton. That is F32. So I solved already so the question C I solved already. The question C, the contact force F32 is actually 12 Newton. Yeah, it's less than the 21.6 before. Yeah, do you see that? Do you see the patterns? Do you actually see the patterns? Yeah, I should actually just throw this off first. Okay, just want to remove this. Remove this. Yeah. Do you see the patterns? I want you to see the patterns actually. Just now, this pushing force is 30 Newton. 30 Newton, isn't it? And then mass 1 pushing mass 2 with mass 1 pushing mass 2 with F12 21.6 Newton. It pushing mass 1 pushing force push the mass 1 with 30 Newton, but mass 1 push mass 2 with 21.6. Yeah, this F12 is 21.6 Newton. You see, less already. And then how about mass 2 pushing mass 3? Mass 2 pushing mass 3, this is F23. Just now this is F12. F12 means mass 1 push mass 2. F23 means mass 2 push mass 3. We got 12 Newton. Yeah, it pushed mass 2 with 12 Newton. You see that? The pushing force become lesser and lesser. The earliest one is the highest, of course, because this pushing force going to push the entire objects. It's going to push the whole thing. This pushing force going to push the whole thing. So of course with higher force. But then mass 1 push only this part. He pushed only this part. Do you see that? He pushed only this part. So that means it had the mass 1 pushing with 21.6. And then mass 2 going to push only mass 3. Which is only this part. That's why the force become lesser and lesser. Again, pushing force 30 Newton is to push the whole thing. That's why 30 Newton. Mass 1 actually is pushing mass 2 and mass 3. The whole thing, mass 2 and mass 3. That's why it become 21.6 only, less than 30. But mass 2 is pushing only mass 3. So that's why it decreased further. The pushing force decreased further, become 12. Okay? That is how it works. Yeah. So actually, this 21.6 and 12, these two forces actually come from the 30 Newton. Or you can say that this 12 Newton actually is a part of 21.6. And 21.6 actually is a part of 30. It's a part of 30. This is a concept of physics, yeah? Okay, I got it. And then let's continue the works. So this total Fy is 0. Okay, because y component in mass 2 is no acceleration, so it's 0. So we just take forces going up, because no acceleration to compare. We just take forces going up positive, forces going down negative. Okay, so it is not normal force negative the weight. The weight is downward, so it's negative. So the normal force is weight. We got the normal force. In case you have friction to find, then you need this normal force. Okay, now mass 3. Mass 3, let's do the mass 3. So mass 3, in x component, we have acceleration. So direction going same direction with acceleration is positive, opposite acceleration is negative. So the equation for x component is ma, of course, because got acceleration. Now the only force for in x component is F23. So F23 is positive. So just put as F23. Okay, F23. And then mass. Okay, mass for mass 3. This one, it should be mass 3 lah. Just now is mass 1. This is mass 2. This is mass 2. This is mass 3. See that? Just now is mass 1. Then is mass 2. Now this is mass 3. Mass 3 is 5 kilogram. 5 kilogram. Let's write down that one. 5 kilogram. 5a. Okay. Actually, we also can cross check what's the value of, you know that this F32 and F23, they are contact force. They are contact force, so we can put it over here. Yeah, can put it over here. Yeah, this one. Yeah, just put it here. We know that F32 is 12. F32 is 12. So F23 should be also 12, isn't it? F23 should be also 12 Newton. So is that correct? Is F23 also 12? Let's cross check. Just now we also got the acceleration is 2.4. We got the acceleration 2.4. So let's substitute inside 2.4 over here. Let's substitute 2.4. 2.4 into this part. Yeah, 2.4 into here. And look at what we get for F23. Acceleration is 2.4, isn't it? Acceleration is 2.4. Let's substitute into here and see what we get for F23. Yeah, let's calculate. 5 times 2.4, we get, oh, the magical 12. We got the magical 12 also. So it's correct. So what is that doing? So F23 is 12. What are you doing over here? Come on. So so you see that F23 is 12, which is, what is, okay, so it is correct. Okay, so it's correct, is which is equal to F32 12 Newton. So it's correct. Cross check is correct. So it's correct. The 12 Newton is correct. Action reaction force should have the same magnitude. That's why I say this F32 just now, this one is 12 Newton. This one also 12 Newton. Yeah, they are action reaction force. Now final part is the y component. I guess you already know about this. The y component, this Fy. So and then you have going up should be positive, no acceleration to compare. Okay, so it is normal force 3, and then negative the weight. Okay, negative the weight, and the normal force 3 is equal to weight 3. Okay, in case you need to find the friction, you need the normal force. Okay, that's it for these questions. I hope you understand and like my channel, and stay tuned for upcoming so many videos. Bye.